Welcome to DebConf. Simon is going to talk about Apt Transparency. Take it away.
Thank you. Nice last presentation, so please sign my PGP key as well. So I will talk about Apt Transparency, and I gave a shorter version of this in the Berlin DebConf a couple of months ago, and one of the feedback there was to focus more on the introduction and motivation. So I will keep that very long to motivate this work, and then a bit about the implementation choices and also what the current status of this work is. So that's the agenda for today. So what is transparency? It sounds like a nice word, and of course we want transparency. Who wouldn't want that? But what does it mean? And what does it mean for Debian? What does it mean for Apt? And this is an honest question. I don't think we can claim that this is a known problem. So let's work out what it means and what we want it to mean. And that's the nice thing about words. You get to define what they mean. When talking about transparency, I think one of the first earlier efforts you have to study are the certificate transparency project that secured the WebPKI. It came about when Google.com was signed by some fraudulent CA, and people wanted a way to be able to track this. There was a lot more on that story before, but that's a simple part of it. Let's Encrypt implements it for many years, and it has been quite successful. So let's see what certificate transparency is and see if we can do something similar for Debian and Apt. So reading the RFC, it's really, I'll read this because it's important to understand what transparency logging means. It has taken me several years to grasp the concept, and it's not very intuitive. We humans like to believe that we understand something at first sight, but I've struggled with understanding transparency logging as a concept for years. So certificate transparency is a protocol to log the existence of server certificates and to allow anyone to audit it. And the purpose is to notice suspect certificates. And the final sentence is interesting, that the intent is that eventually clients would refuse to honor certificates that do not appear in a log. So that's the kind of hidden agenda behind certificate transparency that's now successful and widely implemented. So how do certificate transparency go about doing this? So certificate transparency aims to mitigate the problem of misused certificates by providing append-only logs of issued certificates. And these logs do not prevent misuse, but they make it possible to detect it. And interesting to note that they write that this is a general mechanism, can be used for anything, not just certificates. And that's what my work or this work is more about. So let's come up with some definition of what we want Apt Transparency to mean. My idea is that transparency is the process of monitoring and auditing something, and the goal of establishing one unique, globally shared common understanding of past actions. That's initial attempt at defining what I'm talking about. So this makes sense. We want to monitor something. We want that we are using the same Debian system that everyone else is using. But this sounds very familiar to reproducible builds, right? They are monitoring, they are auditing our packages, and the goal is to establish that we have one and the same unique, global, shared, common way to build packages. So How is this different? Let's look at the keywords here, something and actions. And that's really what sets these efforts apart. Reproducible builds are about looking at binary packages, and the action is to see how they were built, what GCC did when you built the package. And Apt Transparency is more about looking at the apt archive signing private key operation. And the action is the artifact is the signed release in release files. I'll come back to what this means a bit later. So let's update our definition. Apt Transparency is the process of monitoring and auditing apt archive signing key usage with the goal of establishing one unique and globally shared common understanding of a sequence of signed release files. And as you know, the release files are what protects our package archives. So what if we get transparency features for apt? It's not a quality guarantee. Do you remember XZ utils? Those packages were reproducibly built. They looked just fine. And transparently distributed packages will also say that release was perfectly fine. But still, it is about quality. In the same way that reproducible builds is about proving where there is poor quality, and through that raising the lower bar. So comparing these two, if someone shows me two rebuilds of the same Debian packages resulting in differences, I can look at the differences, I analyze it, and that's a problem we should fix. Or people who disagree with the concept of reproducible builds probably disagree this is worth fixing, but hopefully we're a bit part of that. So comparing this, if someone shows me a signed release file that nobody else has seen, that ships me a different version of some package, that's to me a serious problem. I want to look at it, and if I get that data, I can analyze it. Of course, people who disagree that this is important can disagree this is worth fixing. I will skip that. So, key usage transparency is not about PGP at all. It's an interesting topic, and you can say a lot about it, but this is more generic than PGP, and there are initiatives to use something else than PGP for protecting apt archives at all. I'm not sure if they are implemented, but there is nothing PGP specific about this. But we are using PGP technology to protect our Debian releases for many years. I remember when we introduced PGP protection of the archive, but it was many years ago. So there are some details for the PGP case that are interesting to be aware of when talking about apt transparency. So let's talk some about that. A basic question: these signing keys that Debian operates, can we trust them? How are they generated? What software was used? What hardware? Is it a laptop or some hardware device? Where are these keys stored? What jurisdiction? Have they been subject to any legal warrants? There are no real, to my knowledge, answers to these questions. Debian doesn't publish any summaries or knowledge about this. And I assume everyone remembers our Debian social contract, and we will not hide problems, and our priorities are our users and free software. And I think our system security operations can be improved by documenting or establishing some best practices around this. That was some Debian keys. Just looking at the Ubuntu key, they have a 4096-bit RSA key generated in 2018, still protected, still used to protect the last most recent Ubuntu release, and will be used to protect it for another 5 years. So how many employees at Canonical has access to that key? How many will have access to it over the years? A key generated in 2018 is quite old now. I mentioned this in the Berlin DebConf, and someone came up to me and said, did you really look at all the keys? There are 2 keys that are still used to protect the latest LTS release that were generated in 2012. And those are still and will be for the next 5 years used to protect the Ubuntu release, unless they roll it. So that's something to consider, the importance of these keys and the vulnerability of these keys. For the archaeologists among us, we can also remember the times when we used for patent reasons DSA signatures. And Debian release version 6 it's very old by now, but it was protected using a 1024-bit DSA key. And it's still relevant to protect earlier releases. I still use this to build some software for regression testing, and it's also important to protect the integrity of the archive for old releases, for doing rebuilds to prove integrity of our archive. It's also interesting to consider what if RSA is publicly broken? We have to do something. Can we compare this to what we did or how we would protect an old release with DSA? Possibly Apt Transparency may not be sufficient alone to solve that, unfortunately, but it's worth considering. I did look at some other distributions like Triskel. They still refer to an old DSA LGML key as a trusted root for their release, and I'm not even want to go into all these third-party apt archives out there. Most people install packages from other repositories as well, and we probably don't want to know how those keys were generated or stored. But on the other hand, we kind of own this situation by not explaining or documenting a best practice around it. So we should help them to do something better. So the takeaways from considering our PGP keys are really that these are private cryptographic keys. They are online, usually at some connected machine. We don't document how to operate this in a trustworthy manner. We just present, okay, generate your key, sign your apt archive, and continue doing so forever. And I don't think that's good enough. So I think it's fair to assume that there is some risk that some keys have been or will be or are compromised. And we should think about how to mitigate or protect distributions as a result. And transparency mechanisms is not solving this, but it's mitigating that risk, and it's one of the few technologies around. So summarizing what I'm trying to protect against, the attack vector. Let's say you steal one of these keys or get access to it through some online machine, you gain access somehow. You would sign a modified release file pointing to your own packages with some malicious content. After achieving this, you would do a per IP redirection for some victim's IP address, and then wait for that machine to perform some upload or update. This is a simple variant of the attack. There are more complex for upgrades as well. But so stating that in a different or reverse way, what's the threat model for this? And I'm concerned with someone gaining unauthorized access to our apt archive signing key. That's the basic assumption of all this. We could just say that, oh, this will never happen, and we don't have to think about this at all, and I think that's the approach so far. But there are ways to improve it. And also, Apt Transparency won't prevent this from happening, just like any technology won't protect the secure boot keys from leaking from vendors that we saw in the press recently. But it allows end users to not trust signatures that are not publicly logged. So let's try to wrap up the introduction and motivation for all this. It's really the definition about here, and I think this could be improved, but the summary is that Apt Transparency is the process of monitoring and auditing apt archive signing key usage with the goal of establishing one unique and globally shared common understanding of the sequence of signed release-in, release-file publications. I think that's a bit summary. Someone could perhaps write this in a more succinct way, but I think this wraps the core concepts I want to cover. And my vision for where we want to go with this is that through some mechanism we publicly log all release-in, release files in some tamper-proof log, and that systems in some future Debian release, we refuse to trust our release file that aren't publicly logged. We can have multiple logs, but at least one of them ought to be enabled by default. Similar like Chrome has certificate transparency enabled. So that was a very long introduction and motivating why this is a relevant work. I'm sure this can be improved somehow, and there are generic topics here to go into and describe more about what transparency logging and Merkle chains and so on if you want to go in. But this covers the threat model and the attack vector that I think are important. So that's what we should do, or what I hope to argue that we should do. So let's go into implementations. So what it is that protects the Debian archive. Apt calls out to GPG-v for verifying signatures on the release files. And basic idea is to augment that to add transparency checking. Not only check the cryptographic key and verify that it matches, but also check that this key or this signature is a member of a public log or a tamper-proof log. So this doesn't enable any new release files to pass through the system. It only will reject some files if they're not able. I think some people confuse this as a way to get rid of or drop PGP at all from apt, but this is orthogonal to that. So there are many ways to implement this. So I want to keep this kind of high level and not lock down the solution to any particular way of doing this, but to just give an overview of what we can do, not particularly say how this should be implemented. So some of the options I've considered are, the first one was the simplest, that I just wanted to get something to work. It's used in some other places, like and called canary files. So if you want to prove that something exists, just go to some central server and see if it's aware of that content. We have big projects supported by big communities, I think, that implement tamper-proof logging, and Sigstore is one of the well-known. And Sigstore provides two core technologies called Recore, which is a tamper-proof log. It's accept all and publish anything kind of log. It supports PGP, X59, Minisign, whatever. It's a general purpose tamper-proof log, and initial use case was Docker or container images to protect them. Sigsum is another project in a more minimalistic fashion. I will cover them as well. One basic question is also, is this something that should go into apt natively, or is this something that should be done outside of apt? That's another design consideration. We could also piggyback on the certificate transparency work and not have to go into all these choices. I will explain that a bit more. And we can, of course, build our own solutions if we don't like what's out there. Most of the talks or discussion so far has been about apt. We can also consider if there is something that should go into DebConf natively. So let's go through each of these in even more detail. The concept of a canary file is that when you're verifying some release file, just hash it and check if some centralized server is aware of that checksum. This is basically what this code is doing. And it has been in operation for half a year or so, logging all the release files from various distributions and providing clients to do the checking. And there is no Merkle chain here. It's a very simple, old style. There's no crypto-bro stuff here. But, and also, while HTTPS may not be the best solution here, it does tie in with certificate transparency. So you get some cryptographic transparency logging of the relevant key material used here. But of course, the URL, where does that lead? That's the big caveat and big problem with this solution. In my example, it leads to a project that gathers all the release files and publish checksums for them and store them in a Git repository. So that relies on Git security. It's there's a complete archive of release files stored on GitLab currently, and the pipeline for that GitLab project also submits these files to the Sigsum, that should be Sigstore, the Sigstore record log. So all past half-year release files have been submitted to the transparency log. I have written the support for Sigsum and will push that into production when they have only a test log up now. Also, there are some performance considerations with Sigsum. It takes like 10 seconds to submit things to the log. So, Sigstore and Sigsum are two more advanced projects that use a Merkle chain approach instead. And of course, that improves the centralized approach of trusting GitLab. We can solve that to replicate the Git repository on GitHub or some other place, but you still have to trust some big vendor. So Sigstore and Sigsum are distributed transparency logs, and they are designed to store any data. So I looked into both of these projects, and that's when I had to learn Go packaging. I've not touched Go packaging before, and it's an interesting journey. So Sigstore contains two different projects. The Recore, it's a way to append signatures to a transparency log. And this is connected to last talk about open PGP servers. The problem with the Recore log is that attacker can append malicious data to it. But I think this is part of their design to deal with that. I've no real idea of how, but they are committed to be able to transparency log anything that's pushed into their log. Sigstore also has a project called Cosign, which require a private key to sign the material you want to push into the log, much similar to Gunnar's talk about how to improve PGP key server by doing some private key operation from the owner of the key that's going to be logged. It is essentially the same idea. Although this requires yet another private key to handle, so it's a bit of a chicken and egg problem. And another concern with both Sigstore and Sigsum is that they are written in Go and not currently, at least, protected or covered by the security team security upgrades. I think that needs to be changed over time, but. And also the Go ecosystem is very interested. When packaging Recore, it has 390 build reverse depends. And I'm used to maintaining packages where you kind of know all the reverse dependencies by you can type them and remember, okay, I know my package depends on this libenv curses or something like that. But when you have 390 reverse build dependency, it becomes really unmanageable. And I've not even finished packaging Cosign. It's a more complex package. So Sigstore is a huge Go project. Sigsum, on the other hand, is provide a transparency log, but they take a minimal approach to it. And I spent probably a month packaging Sigstore because that's the more well-known project, but then kind of became frustrated and looked at Sigsum, and after 1 hour I had it packaged and uploaded. It's part of Trixie, and I could even backport it to Bullseye. So this is a comment on the Go Rust ecosystem complexity that it's possible to write Go projects without a huge dependency list. It depends on your upstream. I'm not certain about Rust, but at least for Go, that's possible. And I think for both these projects, having C or Python verification clients would be a good contribution. So let's another approach for how to implement this is to piggyback on certificate transparency. So consider that if we for every release file that the Debian archive is creating, we get a certificate that corresponds to the SHA-256 hash of that file. So it's a bit of a ugly solution, but then we can verify this certificate, and you get certificate transparency logging on it. We don't have to rely on Go or Rust, because WebPKI validators are available in almost any language. I think I saw some TLS implementation even in shell script, including PKI validation. I'm not seriously proposing this is a way to go, but it's interesting to think about alternative designs and helps us keep thinking about what the semantics are here and what semantics we want from this. Going into supporting the transparency natively in Apt or outside of Apt, that's two different design choices. We can include this in Apt. We could also put this and say, oh, this is really something that Sequoia or GNU PG should implement. This is just some crypto stuff that has to be dealt at a lower level, and it shouldn't even go into Apt. But no, I haven't seen any implementation supporting transparency logging today. It's an interesting topic on its own, if it's appropriate to have that in the lower level library or not. A third alternative is to wrap the GPGV call to also do transparency log checking, much similar to the Sequoia to GPGV hack that we saw Holger present. I'm not confident that these are the only three choices. Maybe there are some other approach available as well. Oops. Which could be a build it your own kind of model. If we don't want to trust or rely on PGP, I think Julian has a proposal to do raw cryptographic signing of release files where not rely on PGP ecosystem at all. And we could do something similar and design some in-band solution here. Filippo Valsorda has sample implementation of this and calls it a spicy signatures. And I created some samples from this. The top would be a Sigstore cosine blob. So if you're familiar with the release files, they usually contain a PGP armored blob at the end. We could augment that to also include a Sigstore or Sigsum or spicy signature blob, and not consider the PGP armor as the only verification mechanism of the release files, but also add some more claims there. Of course, this not only requires support in Apt, it also requires changes in the Debian archive, so it's even more in depth. And I've also considered if we need to support anything directly for packages. It is possible to sign the Debian packages outside of apt archives, and I haven't explored this at all, so it's more of a question if people think this is something that people are interested in. So those are generic thoughts on how to implement transparency logging in a Debian or apt context. So what is the status of this? And this will be quite short. And Sigsum are packaged in tricks and backports. Sigstore, Sigstore's record is in Trixie. I'm working on Cosign. There is a bug open for native apt support for transparency. I have a package called apt verify that wraps around GPGV to do transparency checking, or at least a hooking system for it. Sorry. And the updated canary store release files into Sigstore. So this is needs to be a group effort, so I'm looking for help, and I'm probably not going to do a lot of work here. I'm just giving some ideas, and I think the community should gather around and do something towards this area. And some final words about trust. And it's easy to forget what you're using, but you're still trusting hardware to run your software. You're still trusting a lot of software. And reproducible builds increase confidence in the packages, and Apt Transparency would increase confidence in the distribution of them. So, thanks. Questions?
Questions? Do we have microphone? We have microphone.
Not really a question, but just a piece of feedback on the transparency mechanisms proposed. So it's very important that one can use Debian by downloading it from Mirror, even if Debian.org is blocked in some, let's say, stupid conference. But at least some of the proposed transparency logging mechanisms introduce DNS and a single domain name as a single point of failure. So in the future work, could you please make sure that if that particular domain name is blocked, there is still some fallback that the user can fall back to, and that like with Debian mirrors, they can contribute to making these transparency logs available in countries that
yeah, that's a good. It's also another. I didn't mention it, but these transparency logs have different properties there. Some operate offline and don't require any connection at all. They can use a transparency statement and verify it offline without any DNS reliance. And some of them are very dependent on DNS or online network infrastructure. And it's a very good observation that this is a concern. You have to think about it.
So I'm interested in who's going to run the certificate log or the transparency logs. how many do you picture that we would need? Who's going to do the verifications, like the monitoring part? And then how do we recover from a log failure?
Yeah, those are very good questions. I think it's part of, we can point the problem to Sigstore or Sigsum and kind of defer that, okay, Debian won't go into providing this infrastructure and just rely on them. That's one option. Or we could implement our own approach to set up, these are free software projects, we can set up our own Sigsum or Sigstore server and run that as an infrastructure. That has quite some cost as well. And part of this, Filippo Valsorda's approach is that there is no infrastructure for validation, that you are doing an offline proof. So that's kind of a publish-only model, and all the verification happens in the client. Then there is basically no operational needs past publishing the release files. But I think it's, I don't have an answers here, but those are good concerns.
Any more questions? I think we have an announcement from our photographer. But before that, we're done with this talk, so one more round of applause.
Thank you.